Welcome back to some more geometry. Today we're talking about the deductive reasoning. So, the beginning of this whole chapter, we talked about inductive. So, inductive, let's kind of go back and talk about it. Get my little pen app right here. Ooh. Inductive. Inductive means when you get a small little bit, like, all right, this thing is true. So let's say I have a senior in my class, and my senior cheated on a test. So I have one senior cheated on my test. So I then make this big conclusion. I'm making this big conclusion that all seniors are cheaters. That's inductive. You're taking a small example and making a big general idea about all of them. That's inductive. Okay? Well, deductive kind of works backwards. Well, so let's kind of think about it as a pyramid. Clear the annotation. So it's like a pyramid. Inductive takes a small little idea and makes big conclusions based off it. So it works from the top, from one small thing to make a big one. Deductive works backwards. We take a general idea and make one little. We start right here, and then we make one little ultimate example about it. So, for example, all balls are round. I have a golf ball, so we can say the golf ball is round. Deductive. You took the general idea of balls and then made one single little example about it. So let's talk about different ways of doing deductive reasoning. So deductive reasoning uses rules, facts, definition, and properties. Those are very important because it asks you what are the 3 things or the 4 things that you can use. You use facts, rules, definitions, and properties to reach a logical conclusion. So you can only make a conclusion based on true statements. So unlike deductive reasoning, we're not making assumptions to create a conjecture. We're using just rules, facts, definitions, or properties, things that are for sure true. So we'll look at the law. There's 2 different ways you can do this: law of detachment or law of syllogism. Law of syllogism. We're going to start with law of detachment first. So law of detachment, you take your if P implies Q statement. So if a true statement, P is true, then Q is true, okay? We can only make logical conclusions. So let's take our condition. This is our conditional statement. So our conditional statement right here. If a car's out of gas, then it will not start, okay? Hey, Sarah's car is out of gas. So the only valid conclusion that we can make for sure is that it will not start. Now, it can be other reasons why she's not start, but no, that's not what we're saying. The only information we know is that she's out of gas. So we can say her car will not start. Let's try this one more time. So let's take a conditional statement right here. If a student passes the entrance exam, they will be accepted into college. Okay. Well, let's say Letitia here, she passed her entrance exam. So what's the only conclusion that we can make? Yeah, Letitia will be accepted into college. So we can only make some exemptions or conclusions based off our statement. Our statement this said only this will make this happen. Well, she did this, so this will happen next. Now, law of detachments can be invalid sometimes. Let's see why. So here it is saying that if a beach is public, then there is no lifeguards. Okay, so that's our conditional statement. Hey, Bayview does not have lifeguards. So we're concluding that Bayview is a public beach. Is that necessarily true? No, we're trying to go backwards here now. We're trying to go backwards. Just because a beach does not have lifeguards doesn't mean it's public. Other way around, if it is public, then it does not have lifeguards. But it doesn't work the other way around. The lifeguards could be off duty that day. The beach can technically be closed, so there's no lifeguards there to work it. There's many other reasons. So remember, you can't go necessarily backwards. You can go forwards, but necessarily backwards when using law detachment. Let's look at law syllogism. So law syllogism is like taking two different statements and trying to just make one more simple statement that implies from the very beginning to the very end. So you have two statements. P implies Q and Q implies R. So we're saying, and these statements right here will always be roughly the same type of statement. So P implies Q, then Q implies R. So if P implies Q and Q implies R, then we can say the very first statement can ultimately imply the very last statement right here. Okay? So P implies R is true statement. So, for example, here's our statement one. Here's our P. If you do not get enough sleep, then you will be tired. If you're tired, then you will not do well on the test. So we're saying P will imply Q and Q will imply R. So our P statement can be broken down like this. You do not get enough sleep. Our Q statement is you are tired. Our R statement is you will not do well in the test. So by law of syllogism, if this implies that and this implies this, then we can say the very first statement, you did not get enough sleep, will imply you will not do well at test. So you could say, if you do not get enough sleep, so our P statement, then you will not do well on the test. So our R statement. We can just kind of cut out this middle statement right here and just go straight from the very first thing to the very last thing. So as you're given work in the homework, you will be given statements. It's going to ask you, hey, use law of syllogism to make this new statement. So we got to recognize what is this part of the statements that are being repeated. Right here, we talked about tired twice. So that means this is the statement we will cut out. So we take our very first statement right here and make it say, if this, then this right here. All right. So just kind of practice that. I'm going to let you guys kind of practice this. So pause it here in a bit. But let me kind of explain this. So the two statements here is if Zach Johnson's scores is lower than the other golfers at the Masters at the end of the tournament. So let me start that over. If Zach Johnson's score is lower than all the other golfers at the end of the tournament, he wins the tournament. And if a golfer wins the Master tournament, then he gets a green jacket. So tell me what's our P statement, what's a Q statement, and what's an R statement, and then go ahead and write a law syllogism. So go ahead and pause it. All right, so you paused it, you checked it out. So let's kind of look. So our P statement here is Zach Johnson's score is lower than the other golfers. It's a long one. Golfers. Okay, so his score is lower than the other golfers at the end of the tournament. At the end of the tournament. Okay, so that's our P statement. I'm going to do that in black. P statement. Our Q statement will be he wins the tournament or a golfer wins the tournament. So we're going to kind of generalize it because it's kind of about him specifically. But we say, hey, a golfer wins the tournament. All right, so Zach Johnson's scores is lower than the other golfers at the end of the tournament. A golfer wins the tournament. And if a golfer wins the tournament, then our R statement can be you win a green jacket. You win a green jacket. So we could ultimately say that, hey, P, Zach Johnson's probably playing at the Masters tournament. He's trying to get the lowest score so he can win a green jacket. So we could ultimately say Zach Johnson's score is lower. So if Zach Johnson's score is lower than the other golfers at the end of the tournament, then he wins a green jacket or gets. I think it says gets. So let's use the terminology. He gets a green jacket. Sorry, that was long. Should have written out that before, but it's okay. So again, we took out the part that was the redundant part is he wins a tournament. If a golfer wins the Master tournament, that part. So we kind of took that out and say, hey, all right, if this, then this right here. That's the law of syllogism. So there'll be a couple of times you're going to give you statements like that. You're going to have to blend them together. Take out the middle part and go from the original statement P to the ultimate statement R. Okay. The way we can kind of look at that in life and the way we kind of relate this to life would be like, if I do my work, I get good grades or get passing grades. We'll say passing grades. And if I get passing grades, I graduated high school. So we can ultimately say, if I do my work, I will graduate high school. Or even more personal, if I do my homework in Mr. Carrillo's class, I will get a passing grade. And if I get passing grades in Mr. Carrillo's class, I will pass his class. So if I do my work in Mr. Carrillo's class, I will pass his class. Plain and simple. All right, y'all. Have a great day. Let me know if you need anything. Please, please, please hit me up if you need some help. Bye.